Hawthorne Elementary. Hola, bienvenidos. Hello and welcome, Hawthorne Elementary, to Sci-Friday with me, Scientist Smith. Today we are going to go on a journey learning the states of matter. Everybody say matter, matter. Matter is everything around us, things that take up space. For instance, my glove here, this table, all of my goodies in my basket, everything that we see. Solids, liquids, and gases. Everybody say solid, solid. So this is a solid right here. And then I have another solid right here, which contains another state of matter known as liquid. Everybody say liquid, liquid. So see, water, liquid. And then the other state of matter is gas. Everybody say gas, gas. Gas is all around me. Actually, I'm outside and it's also around you. Outside, we really can't see gas molecules unless it's really cold. So for instance, say I have something I can show you that's a little cold. That's going to show you those gas molecules. So this is liquid nitrogen. Liquid nitrogen. See that liquid coming out? So that liquid nitrogen is so cold that it's cooling down the air around us. Have you ever been outside in the wintertime and did this? And then you seen your breath before? That's because of condensed gas vapor. So inside of here is liquid nitrogen, a liquid. So liquid nitrogen doesn't like to stay liquid at all. It would rather be in its gaseous state of matter. So it would rather be a gas. So what's happening is this liquid is evaporating. Everybody say evaporate, evaporate. So it's evaporating, turning from a liquid to a gas and expanding back out into the atmosphere. Now, there was a balloon in here. See this balloon? This balloon once was big and inflated. But as it got cold, it got a little bit shrunk. Let me see. I have one inside of here. That doesn't even sound like a balloon, does it? It sounds like more of a, yeah, like a plastic bag, right? But I'll give you a closer look. Check this out. So look, you can see it also is expanding back into its natural state. But it was shrunken up just a little bit. But that's just material functionality. We'll learn about that today during our experiments that we have. So let's start with our experiment number 1. Oobleck! All right, Oobleck time. So go ahead and pull out your container and your spoon and your cornstarch. So this is the beginning of our process. Oh, and your food coloring. Food coloring, container, cornstarch. So go ahead, open up your container of cornstarch. Be careful with this because cornstarch is very, very tiny, tiny particles. And if you allow it, it will fly all over the place and it gets really, really messy. So you want to, as you can see, it got a little bit on my hand, but it's okay. It washes completely right off. Now we'll learn more about this here in a little bit. So go ahead and maybe use about half of your container of Oobleck, or half of your container of cornstarch. And also we need water. Water for this because we are going to mix two things together. The liquid, which is our food coloring, if you want to do food coloring, and our water, mixed in with the solid cornstarch. So what this is going to create is something called a non-Newtonian fluid. Try to say that word. Non-Newtonian fluid. Again, non-Newtonian fluid. All right, good job. So non-Newtonian fluid essentially means that it's not a liquid, it's not a solid. It's kind of like both at the same time. Let's dig in. So go ahead and grab your food coloring if you choose to use food coloring. I think I'll use a blue. Let's do some neon blue action. So you just dribble, dribble, drizzle, 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 drip, 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 all around your cornstarch, just like so. And next, we don't want to put in too much water at one time. What you want to do is allow yourself to see just exactly how this cornstarch is going to mix in with little bits of water at a time. Say a cup at a time. So not even a full cup, maybe a quarter a cup. It's up to you. You right now are the scientist. So use this time to explore and appreciate the experiment for what it is. So I'll just put quarter cup right there, and you can see already there's some liquid that's starting to flow. See, it flows. The liquid flows freely because those molecules are a lot looser than these solids. So you see, solid molecules are more compact. Liquids are a little bit more flowy and loosey-goosey. Gas molecules, you know how they are. Look at this. Trap that gas inside, but if I let go, then whoa, all that gas just keeps flying all around because gas molecules are very, very, very hyper. They move all around real fast. Solids, they stay still. Liquids, they kind of go with the flow. So let's go ahead and I'm gonna put on my gloves. You don't have to put on your gloves at this point. I'm gonna use these gloves just to keep everything a little bit more clean out here in this parking lot. It's a little hot too in this parking lot. All right, now go ahead and get your hands on in there and mix that liquid in with the solid. And what you'll see is it starts to get stiff. Now there was water that's flowing, but now it's a little bit stiff. So I'll pull up this part right here. There's still some solids down in there, more the powdery solids. But if I pull this up here, you can see this looks like some type of solid, right? But watch as I allow it to relax. As I allow this to relax, you can see it's kind of having some type of liquid property as it starts to crumble and fall into my hand. Now let's add a little bit more liquid to this. A little bit more water. Just like so. And move it around with your hand. And you'll feel it have a lot of give. It's going to have a lot of give depending on how much water you're putting in here. I'll come and give you all a closer look in my container here. See? So, right now, I have a nice amount of water in here, which allows you to see just how fluid this oobleck is. But it also, look, I'm squeezing as hard as I can, but it still has a lot of solid tendencies and liquid tendencies at the same time. Thus the term non-Newtonian fluid. And you can see that's a cool color right there. Just like that, I try to squeeze it and it crumbled. But look, it still drips as if it's a liquid. That's because the molecules are a lot more relaxed. So sometimes when you're stiff and rigid, you're acting more of like a solid. But if you're a little bit more looser, just like here, there's water that's inside of this part. But over here, there's more solids in this part. So it all has a play on concentration. Everybody say concentration, concentration. A little drip action. Concentration. So concentration is the amount of one thing in a combined mixture. So for instance, we have a mixture of liquid and solid here. So we have a concentration of liquid and we have a concentration of solid. One might be more than the other, or they might be equal, depending on how you mix them. And it's all based on the mathematics. So for instance, this has a real high concentration in liquid because you can see it's more fluid. It acts more like a liquid. But if I was to take this and put it over here with some of the solids that I have here, like so, now, look, this has a lot more solid inside of this piece that I picked up here. So the solid concentration has increased, thus the property of this material acts as if it's a solid. Now if we were to take this and say pour some water on it, you'll see now it starts to drip. And you see we've increased the concentration of water, so now with it being more of a fluid, it acts more of a fluid. Boom. But you can play with this all day long. Oh my gosh. The best part, what you should do is take some water, and then once you get it to a nice consistency, just kind of put your hands down in there, and you'll feel how much it pushes back if you push real hard. But if you just let your fingers ease into it, it kind of allows it to kind of become one with the liquid, and it kind of flows in, and you can play with it more like quicksand. And here's another fun thing you can do without making a mess, at least. See that right there? It's just kind of a real great sensation for kindergartners. It's a good tool as far as texture goes. Um, for the fifth graders, you should do more of a concentration play. So take 3 different bowls, mix them up differently with different concentrations of liquid and solid, and play it that way. But yeah, Oobleck! Oobleck! So you can see just right in there, there's a lot of water that is flowing inside of my container here, but there's still some solids in here. Now, if I was to take some more of my cornstarch, which I have here, and sprinkle my man, sprinkle on top of there, you'll see, I'll show you, solids are sitting and resting right on top. But if I come and move that liquid and interact it with those solids, now you see it starts to have some type of pushback because there's a lot more solids that are interacting with our liquid. And if I take my spoon here, see, it's tough. Like I can't even dig up under there because it's starting to become such a solid. But this part right here, it's a lot more fluid because it has yet to mix in with those solids. Now, it's probably at a good consistency to where you can take your finger and just poke at it. And you can see nothing is coming off from my finger because when you give this some type of force or energy or pressure, we push down on it, the solids push back. So what we're doing, of course, if you push real hard, really fast, on and off, you can't dig deep down in, because if you do that, remember, if you slowly penetrate and slowly push your fingers into the liquid, it then becomes more of a liquid, and then now look at that. Earlier when I was just doing nothing came off, but Bumbarooski, that's all right. But now you can see even on the tip of my fingertips, it went back into solution because I am reacting it. But yeah, another fun way to play with Oobleck. All right, now I gotta clean my hands. Pause. All right, let's put this to the side before we get too messy. Obviously, we could play with this all day long. You can too. Let's move on to some bubbles. All right, so this next activity, you should get out your containers, whether it's a cup or a glass. Get out your corn syrup, your detergent, dish detergent, and we'll get to this a little bit later. Make sure you have this, your paper towels, or extra cloth if you have a cloth, and your rubber band. Rubber band, rubber band. Put that all to the side right here. We'll get to that here in a second. And a straw. If you have a straw, that also helps when it comes time to blowing bubbles. Put that in there so it doesn't go flying away. All right, so go ahead and take out 2 cups and make sure you have your water on hand as well. We need water. So we'll put some soap in one, soap in two, a little bit more soap, a little bit more soap. And this one will also need some soap in as well. So let's do that. Boom. So in your two containers that you have in front of you that have soap in them, what we're going to add to one of the containers is our corn syrup. So go ahead and add some corn syrup into one of the containers, just about equal parts. Remember, you're the scientist at this point, so you can make different variations. You can make one with just 1 spoon, 1 cup with 10 spoons, a whole experiment. All right, so now we have 1 cup with both corn syrup and dish detergent, and then this one just has dish detergent in it only. And then let's go ahead and add our water. Let's go ahead and give it a mix. You can use your finger. Just give it a nice, good mix. And you can feel the syrup over here, the one that has the syrup. If you don't want to use your finger, you can use a spoon. It's not going to hurt you. It's just soap and sugar. Soap and sugar. And over here, of course, is just soap. Let's go ahead and wipe that finger off. So what we're doing today is learning about surface tension. Everybody say surface tension. So surface tension, for instance, when it comes to this bubble right here, there's a bubble. There's a lot of bubbles on here. These bubbles are very fragile. For instance, this balloon here. This balloon is elastic. Elastic. Everybody say elastic. Or you can say elasticity. Elasticity. So this balloon stretches. And put a little air in it. So if I was to take this balloon and try to squeeze it, you can see that it's not popping. That's because it still retains its elasticity. The surface of this balloon is not going to pop because it still has some of its functionality. But if I was to now, if I was to take this and squeeze it, it would more than likely pop in my face. So I'm not going to do that. But what I'm trying to show you is that now we have degraded the functionality of this balloon to a certain extent because it is a lot more fragile than it was early on. So I could pop it just like that with my pinky nail. But still, that surface tension, for instance, was very weak, just like the surface tension of a bubble. For instance, if I was to take my straw here, and put it inside of here, and let's do this. Go ahead and make some bubbles. Everybody loves to do this in a chocolate milk or anything that can form bubbles. Now, if you try to do this in just water, it really doesn't work as well. The reason why it works so good in milk is because milk is very, very fat, and the surface tension of those bubbles is not as weak as it is if you was to do water, or for instance, this right here, which is soap and water. Let's go ahead and try it. Boom. So right here, we have a nice mound of bubbles. Hopefully it stays together. And if you look carefully, one thing I'd like to challenge you to do is try to count how many bubbles are actually touching one another. Now, look at it. The wind is popping these bubbles. I'm not even touching them. The wind is blowing so hard that it's popping the bubbles. That's because the surface tension of these bubbles are so weak. And I could, of course, pop with my finger because my finger is so rough compared to these bubbles that pop, 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 pop. So how can you grab a bubble? Can you grab a bubble? Is it possible to grab a bubble? Let's find out. All right, so we have some bubbles here. So if I wanted to grab these bubbles, nothing's possible. It's not letting me grab that bubble. Nothing is actually touching my hand and staying on my hand. But if I was to want to grab a bubble, you must become a bubble. So to grab a bubble, you must become the bubble. So everybody go ahead and take your hand, and dip it down all nice and lathered up. Now you have soap solution on your hands. So the next time that you go to pick up a bubble, the bubble is easily allowed to slide right on your hands because your hands are not as rough as they were when we first started, before you put the solution on there. So let's go ahead and try it. Go ahead and do this. Now, just like that, look, the bubbles are on my hand, and they're staying because my hand is just like them. So they cool, they're hanging out until some force comes, and then of course when you apply enough force, then you of course degrade the surface tension, and thus it collapses down to its just liquid form. Now inside of these bubbles is carbon dioxide gas. Everybody say carbon dioxide, carbon dioxide. So carbon dioxide comes from within us. So we just breathe out, and it's a gas. That gas is called carbon dioxide. It travels through this tube into this water, which has soap in it, and the soap forms a bubble which traps that gas inside. We can't see that gas because once it's not colored and it's not condensed gas vapor, but it's in there. It's trapped inside that bubble. Now you can tell all these bubbles keep popping, right? All these bubbles keep popping, pop, 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 pop. What we're going to do now is go over to our cup with what we're going to do now is go to our cup that has our syrup. So the syrup allows this to become sticky, and of course, as stickier, the stickier it is, the stickier it gets. So these bubbles aren't going to pop as easy. Let's do it. Actually, let's make it even better and just do it all in the big, large one. Let's go ahead and add some water to that, and some more sticky syrup. There was soap already in there, so no soap needed. Give it a nice swirl, and let's see what happens. You should see it start to come out and form, and it should stay one complete solid. Let's try it. Uh-oh. Let me try to keep it on the table. So now you can see all these bubbles aren't as poppable, if that's a word, as possible, because they're all sticky now, and my hand is starting to get even more sticky as I rub it in, and they start to fly away. All right, bubbles. So when it comes to this tube here, let's go ahead and put some syrup in a cup, and some soap in a cup, some more soap in a cup, some water. What we're going to do is mix it up a little bit. Mix, mix, mix. If you have a paper towel works too. I'm going to use my cloth, just like I have here, and the rubber band man. So what we're going to do is make a funnel or tube of bubbles. So go ahead and take that, dip that in your solution there, just like that, and then blow out, just like that. A little bit more. Bubbles are so fun. All right, I can play with bubbles all day long. Let's transition into our next experiment. So let's go ahead and get your vinegar, your bottle, baking soda, spoon, and yeah. Then we'll get to the 2-liter and the dowel rods or skewers, whichever you have, and your duct tape. All right, let's go ahead and pull out your balloon and also your baking soda. Let's go ahead and open that on up. Open up the baking soda, open up the baking soda. All right, the baking soda don't want to open. There we go. Baking soda's open. Now, this balloon is elastic. Remember that word, elastic or elasticity. So let's go ahead and stretch out the top opening just like that. You can get help from a partner Just go ahead and open that up. You can see that it is hollow. So now I'm by myself. So what we want to do is take 2 or 3 spoons of baking soda and just inside you go. Depending on the size balloon you have also. So if you have a smaller balloon, you can only put so much in. So I put maybe about 2 in there. And you can see the baking soda comes right off. So inside of a balloon, you have baking soda. Make sure you don't have any clumps in there. So just kind of wiggle it around, move it around. Make sure it's all a nice fine powder. Set that to the side. Next, let's go ahead and take our container that we're going to use, whether it's a 2-liter or an 8-ounce or a 12-ounce or a 16-ounce as I have, or a 22-ounce or whatever size container you can find. Then we're going to add food coloring. So your choice of food coloring, I'll add red. Take some food coloring, drip, 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 drip. Close that up. Then we add our vinegar. Vinegar, another name for vinegar is acetic acid. Try to say that word, acetic acid. Also, vinegar. So take our vinegar, carefully pour it in here. Remember, vinegar has a very, very smelly smell, so pour slowly and carefully. In goes the vinegar. You don't want to put too much in there. Again, if you have multiple bottles, you can, 5th graders, set this up as a time trial for vinegar that starts up here, and then your next bottle comes down to here, and so on and so forth, and see how long it takes to react and how much expansion you get out of your balloon. Now, what we're going to do is take our balloon, which has the baking soda in it. We have to take this top part, open it up, and seal it right around the top of your bottle. Now we want to do that just so that it's nice and snug, but the solids, for instance, are hanging over the side. It's like it's going to sleep with its bonnet on. All right, so now we have that on there nice and tight. What we're going to do here is what's called an acid-base reaction. So our acid is acetic acid, and our base is this baking soda. Another name for baking soda is called sodium bicarbonate. Try to say that. Sodium bicarbonate. Sounds so fancy, but it's just baking soda. All right, so now what we're going to do is take this baking soda that's dangling over inside of the balloon, and we're going to top it and flip it over, and all those solids then react with that liquid, and you can see it's starting to form a gas. So we have all 3 in one. So we have solids, liquids, gases galore. Solids, liquids, gases galore. So what we have here is an expansion of gas in our balloon. So who can guess what this gas is called inside? Now remember, this balloon wasn't inflated at all before, but now it is because we created some gas, y'all. This gas is called carbon dioxide gas, and you can see it's starting to take shape as more and more and more as our solids mix in with our liquids. I'll set this off to the side here, just in case it doesn't topple over and fly away. We don't want that at all. Safe science, safe science, safe science. All right, now let's move on to the big finale. This is one that I'd like to see some of you all's videos, if possible. So what we're going to do is take our 2-liter. Make sure you have a cork that fits that 2-liter. Try it, on and off, on and off. Make sure it's easily on and easily off. Set that to the side. This case, you don't have to add food coloring. You can if you'd like. Why not? Let's add some. Yeah, let's do blue. Blue's cool. So let's take some blue food coloring. Drip, drip, drip. We got our food coloring in there. Now we got our skewers. So these skewers are going to be what our rocket sets on. So if you can see, I'll try to hold all 3 at once. So this is what we're going to essentially create. So that when we fill this with vinegar, say about to right here, then we dump in a lot of baking soda, then cork it, we can flip it upside down, and the bottle will rest on these 3 tips. That's the rocket, and then it should shoot straight off in the air. But let's try. All right, first things first, let's get our tape. We'll do one skewer at a time. So get your tape and rip your tape and take your skewer and just attach your skewer to your tape. Now, what we want to do is make sure that it's all uniform. So find a spot on the bottle, for instance, this line right here, so that they're all, or let's try, let's midway through the handle part and take that on, because remember, we want it to have some type of room from the ground, which will essentially be here, and the actual blasting point. Excuse me. So this is what we got so far. I'll show you. This is what we got so far, which works. And then you want to do this all the way around. So let's continue. The sun came out, y'all. The sun. So let's make sure it's all even, as even Steven as possible. You can eyeball it, line it up, boom. Got two. And then the third one, you want to make it essentially as if it's like a triangle. Sort of triangle. Triangular. Make sure they're even, because it won't really work as good if they're not even. You'll have a crooked launch. We don't want no crooked launches. Take third one on, and we should be ready to rock and roll. And then we're gonna go all the way around and make sure that they're all sealed with one big piece of tape. Right there. Remember, no such thing as perfect. Just make sure you continuously putting effort towards what you want to accomplish. Strive for greatness. So let's go ahead and attach the tape all the way around town. All the way around town. See? Now we have our essential. So what we're going to do is fill it with vinegar. Then we're going to add baking soda. Of course, it's going to start foaming right away. So we have to put as much in there, put a whole lot in there, and then cork it, flip it. Right now is where we test the balance. So we see it's balancing. It's a good balance too. So it may shoot off that way a little bit, but hey, all right, it's so science. If you don't have a funnel, you can get a piece of paper like so. Make sure you just make a funnel like that. Make sure it's a nice tight funnel so that your solids can get down into the bottle very freely without getting clogged up or backed up. Make sure you have a piece of tape on your hand already so that you can stick it on there when you get it formed. All right, let's try this one more time. There we go. So, funnel, just like that. And tape. Remember, make sure that it can fit into your container. Our vinegar, boom. Pour in our vinegar slowly. That's about enough vinegar right there. Just about enough to fill it a quarter of the way. And get your cork handy. Get your funnel going. Open this up. All right. All right, Hawthorne Elementary. That didn't go as planned, as you can see. But hey, that's experimenting. The joy it brings, the learning that you get from it, developing your skills and the knowledge. Love it. Remember, practice safe science. Always, always practice safe science. Enjoy yourselves and practice these experiments over and over again to test them out in different ways. That's the nature. Thank you so much, Hawthorne Elementary. I appreciate your support. I really hope you all enjoyed Sci-Friday as much as I did. I look forward to seeing you all next time. Adios.